this video, I am going to discuss the basic concepts of position, distance, and displacement in describing the motion of an object. An object's location is defined as its position relative to some reference point, often the origin of an axis. One way of locating an object is with a position vector r, which is a vector that extends from a reference point, usually the origin of a coordinate system. In unit of vector notation, it can be written as r is equal to x I hat plus y j hat plus z k hat, where x is the x component, y is the y component, and z is the z component of the vector. For example, an object whose position is denoted by the rectangular coordinate system -4, 2, and 3 has a position vector r is equal to -4 I hat, 2 j hat plus 3 k hat, where -4 is the x component, 2 is the y component, and 3 is the z component. An object's position can be described from its distance and displacement. Distance and displacement are two quantities that may seem to mean the same thing, yet have distinctly different definitions and meaning. Distance is a scalar quantity that refers to how much ground an object has traveled during its motion. For a person traveling from Santa Catalina, Ilocos Sur to Mariano Marcos State University, he must pass through Cabugao Church, the Ilocos Norte border, Badoc until reaching MMSU. In describing distance, which is a scalar quantity, the direction of its motion is not considered. On the other hand, displacement is a vector quantity that refers to how far an object is from its starting position. It is the overall change in position of an object. Displacement, being a vector quantity, must be specified with a given direction. Displacement, usually denoted by delta x, is the change from one position x of 1 to another position x of 2. So let's try to solve problems on your module. So we have example 2.01. A skater travels 180 meters going to the east, then goes back a distance of 140 meters, and continue moving to the east with a distance of 100 meters. Determine the total distance traveled and the displacement of the skater. So for the first unknown, we have the distance. So we are going to identify first the movement of the skater. So we have 180 meters going to the east, then 140 meters back in an opposite direction, and another 100 meters continue moving to the east. So for the distance or the total distance traveled by the skater, you are just going to add the distance or the movement taken by the object. So we have 180 meters plus 140 meters plus 100 meters, which is equivalent to 420 meters. So if you look at the total distance, it did not consider the direction of the movement of an object. So for the displacement of the object, we are going to consider now the direction of its motion. So we have 180 meters to the east, letting it to be positive. Then 140 meters which goes back, that is why it will become negative. And 100 meters positive, which is still going to the east. And by applying algebra, we have a result of 140 meters going to the east. So that is the difference between the distance and displacement of the skater. So next, for example 2.02, the position vector for a particle is initially at 3 I hat plus 2 j hat plus 5 k hat, and then later is at 9 I hat plus 2 j hat plus 8 k hat. What is the displacement from position r sub 1 to r sub 2? For us to visualize the position of the particle, we will be needing a three-dimensional coordinate system with x, y, and z as its axis. The location are shown using the GeoGebra app. The displacement of the particle is just a straight line connecting position r sub 1 to position r sub 2. For us to determine the displacement of the particle, we need to subtract the positions of the particle by its component. So for the x component, it's 9 minus negative 3, which is 12. For the y component, it's 2 minus 2, which is 0. And for the z component, it's 8 minus 5, which is 3. So the displacement of the particle in vector notation form is 12 I hat plus 3 k hat. And the magnitude of the displacement can be taken by taking the root of the sum of the square of its component, that is 12.369 units. On try it yourself portion of the module, the first one is to determine the distance and displacement traveled by a runner along a circular track with a diameter of 250 meters. The animation illustrates the motion of the runner. For a total distance covered by the runner, it is equivalent to the circumference of the circular track, and its circumference is given by the equation 2 pi times r, where radius is half the diameter of the track. So the total distance run by the runner is 2 times pi times 125 meters, which is 785.40 meters. As for its displacement, it is equivalent to 0. But why? For a runner to make a complete round, he needs to return to its starting point. That is, starting position x sub I is equal to final position x sub f. And displacement is the difference between x sub f and x sub I, which is equivalent to 0. Next one, a student drives from his house going to school with the following displacement: 0.5 kilometers east, 1.25 kilometers north, 1.75 kilometers west, and 0.45 kilometers north. Determine the total distance and displacement of the student. The image shows an illustration of the path of the student. For the total distance, we just add the magnitude of each movement. That is 0.5 kilometers plus 1.25 kilometers plus 1.75 kilometers, and lastly 0.45 kilometers, which has a total of 3.95 kilometers. So for total distance, the direction of each movement was not considered. And the displacement of the student can be computed first by combining displacements along the same axis. That is 1.25 kilometers north and 0.45 kilometers north, then 1.75 kilometers west and 0.5 kilometers east, leading to 1.75 kilometers north and 1.25 kilometers west. We have now the sum of its component, so by applying Pythagorean theorem, we can solve the magnitude of the displacement, that is equal to the square root of 1.7 kilometers squared plus 1.25 kilometers squared, which is equal to 2.11 kilometers. And using the tangent identity for the angle, that is, theta is equal to the inverse tangent of 1.7 kilometers divided by 1.25 kilometers, which is 53.67 degrees. Therefore, the displacement of the student from his house going to school is 2.11 kilometers, 53.67 degrees in a northwest direction. And for the last item, if a bat flies from xyz coordinates negative 2 meters, 4 meters, and negative 3 meters, coordinates 6 meters, negative 2 meters, negative 3 meters, what is the displacement in unit vector notation? The image shows the initial location of the bat. Then, it moves to second position. In unit vector notation form, the first position can be written as r sub 1, which is equal to negative 2i hat plus 4j hat minus 3k hat. And the second position, r sub 2, is 6i hat minus 2j hat minus 3k hat. The displacement of the bat can be determined by subtracting the magnitude of each component. That is 6 minus negative 2 for x component, which is 8i hat, negative 2 minus 4 for the y component, that is negative 6j hat, negative 3 minus negative 3 for the z component, which is 0. So the bat moves 8 units to the right or to the x-axis and 6 units backward or to negative y-axis. So the displacement of the bat in unit vector notation is 8i hat minus 6j hat. In summary, the motion of an object can be described first based on its position, distance covered, and its displacement. In the next video, I will be explaining other ways of describing motion of an object, which is based on its speed, velocity, and acceleration.